Good day, great minds. Welcome to another edition of our Maths Marathon class. Like I said in episode 1 of this logarithm, today we're going to look into the laws of logarithm and then solve one or two examples. Now let's start with the laws of logarithm. The first law of logarithm says log to the base a of a equals 1. And the second says log to the base a of m raised to the power p is the same thing as p log to the base a of m. And the third one says log to the base a of m times n is equal to log to the base a of m plus log to the base a of n. And this can be expressed in a sentence as the single logarithm of products is equal to the addition of their separate logarithm. Of their separate logarithms. The single logarithm of products equals the addition of their separate logarithm. Now the fourth one says log base a of m over n is equal to log base a of m minus log base a of n. And this can also be said as the single logarithm of a fraction is equal to the difference of their separate logarithms And then the last of the laws of logarithm says log to the base a of m to base b to another base b is equal to log to the base b of m over log to the base b of a. And we can say that the logarithm of a number can be expressed in a different base base. If the logarithms of the original number and the base are written as fractions. Now, let's look at it. The laws of logarithm. First says log to the base a of a equals 1. Of course, we know log to the log of a number to the same base. Okay, I didn't write it here. This is log of a number to the same base equals 1. Log of a number to the same base equals 1. That's the first one. And the second one says log to base a of a number m to the power p is just the same thing as taking that power, bringing that power to the front, and then multiplying it with log to base a of that number. Just bringing the power before it and then multiply it with the logarithm. Now the third one says log to the base a of m times n equals log to the base a of m plus log to the base a of n. Remember when we did in indices, the laws of indices that says a to the power b multiplied by a to the power c is equal to a to the power of b plus c. That is what this thing is talking about. Log to the base a of m times n equals to log to the base a of m plus log to the base a of n. That's the single logarithm of products equals the addition of their separate logarithms. Now the fourth one, log to the base a of m over n equals log to the base a of m minus log to the base a of n. The same thing when we did the indices. A to the power b over a to the power c is equal to a to the power b minus c. That is what is replicated here. Log to the base a of m over n equals to log to the base a of m minus log to the base a of n. That is the single logarithm. The single logarithm of a fraction, of course this is a fraction, equals the difference of the separate logarithms. And then the last one which is number 5 says log to the base a of m to another base b is equal to log to that new base of m over log to that new base of a. And it says the logarithm of a number can be expressed in a different base. Logarithm can be expressed in different base if the logarithms of the original number and the base are written as fraction. This is exactly what we did here. This is the logarithm to the base a of m to another base m is just equal to log to the base b of m, the first number, over log to the base b of the base of the original number. So let's look at a few examples. The first one says, without using tables, find the numerical value of log to the base 7 of 49 plus log to the base 7 of 1 over 7. Number 1 says log to the base 7 of 49 plus log to the base 7 of 1 over 7. Of course, from the laws of logarithm, this is the same thing as log to the base 7 of 49 multiplied by 1 over 7. the logarithm of products equals to the different logarithm of the addition of the separate logarithms. So this, from here we have that log to the base 7 of course, from here we have this, we cancel this. What do we have? 7. So this is what's log to the base 7 of 7. And the log of a number to the same base equals what? 1. Right? Now, the second one says, number 2, I will simplify log to the base 10. Log to the base 10 of a to the power 1 over 3 plus 1 over 4 log to the base 10 of a, then minus 1 over 12 log to the base 10 of a to the power 7, a to the power 7. And this is the same thing as log to the base 10 of a raised to the power 1 over 3 plus, remember when we say the log of a number raised to a power is equal to the product of that power and the log. So this is the same thing as log to the base 10 of a raised to the power 1 over 4. This is the same thing as minus the same thing on this one, log to the base 10 of a raised to the power 7 times 1 over 12. And this is the same thing as log to the base 10 of a to the power 1 over 3 plus log to the base 10 of a to the power 1 over 4 minus log to the base 10 of a to the power 7 over 12. Log to the base 10 of a raised to the power 7 over 12. If you look at this, we have, if we put brackets here, this is the same rule as the log of a product can be expressed as the different logs, the addition of the different logarithms. To employ this one, this is minus log of a fraction can be expressed as the difference of the separate logarithms. Now from here, now we have that log to the base 10 of a to the power 1 over 3 multiplied by a to the power 1 over 4 all over a to the power of 7 over 12. Now this, from the laws of indices, two numbers with the same base multiplying each other is just the addition of their powers. So, and that is log to the base 10 of a to the power 1 over 3 plus 1 over 4, then all over a to the power 7 over 12. And when we add the numerators, log to the base 10 of this, what is the LCM of 3 and for this, that is 12. That is to the base of, then 3 and 12 is 4. 4 times 1, 4, plus 4 and 12, 3. 3 times 1 is 3. All over a to the base of 7 over 12. And that is log to the base 10 of a to the power 7 over 12 over a to the power 7 over 12. And this is equal to log to the base 10 of what? 1. And log to the base 10 of 1 equals what? 0. Do you believe? Now, okay, when we have, we said that 1, okay, we said from here now, that the log of a number is the power to which the base will be raised to give that number. Now, the base of this number, now let's see if it is correct. The base of this number is what? 10. Now, what power would you raise to 10 to give you 1? It is raised to power 0 or to 1. Plus 1. 10 raised to power 0 is equal to 1. Of course, any number raised to power 0 is 1. So, from the definition of logarithm, log of a number is the power to which the base will be raised to give that number. Now, the last one, which is this one, I think we'll move that one to another episode because the length of the video is already long.